For question number 2, I wrote down the equation for the Maclaurin series to start. It's similar to the Taylor series, except for a equals 0. And then I found my derivatives to start writing out my series. So the first derivative of the term we were given, which is e to the x squared. I should write that in the front here, e to the x squared. So the first derivative we get from e to the x squared is 2x e to the x squared. And solving for that at 0 equals 0. And then the next term is 4x squared plus 2 times e to the x squared. And put in 0 for that, you get 2. And then for the next few terms, I did use an online calculator to solve out to save on time. So I just wrote out what their plug-in in 0 terms are. We have 0 and 12. Then you write out the series. As you can see, you have your first term, which is e to the 0, because that's what we found over there, squared plus 0 plus 2 over 2 factorial x squared, because for the second derivative, we got a 2. That's why it's in the second spot. The first spot is the 0th derivative, kind of. Sorry for not explaining that. This is 0, 1, 2, 3, 4. So then 3, I also got a 0, so it's just kind of doesn't matter. I don't need to really solve it out. 4, we got a 12 for the fourth derivative. So we got 12 over 4 factorial times x to the 4th. When you do the math and simplify these, e to the 0th squared is just 1 plus x squared once you solve that out, because 2 factorial is just 2. And then plus x over 3 factorial to get, yeah, that is the final answer. And then this is the series for it. I didn't really know which part to answer, so I did both. And then the series for e to the x squared is x to the 2n over n factorial. You get this through kind of u substitution. You make u equal x squared and then just solve it as normal, plug it in at the end. B is where it was asking for the